Hi, and welcome to a new lesson from Easy Chemistry. This is Mr. Kusai, and today we're going to start a new lesson. It's about the rate of chemical reactions, and our first lesson is going to be a model of reaction rates. Our objectives for today are to explain how average rates of chemical reactions can be calculated from experimental data, and to understand the collision theory and explain how the rate of chemical reaction related to it. Our vocabularies for today are the reaction rate, collision theory, activated complex, and activation energy. Look at this image here. This is an apple that we cut in 0 hour, the first hour, and then after we waiting for 1 hour, this is how it will look like. And if we wait after 2 hours, this is how it will look like. That means this chemical reaction occurs, but it needs time to finish this chemical reaction. So, what is the reaction rate? The reaction rate is the change in concentration of a reactant or a product per unit of time. Look at this flask, for example. These particles, the purple one, are the reactants, and after 20 seconds or 10 seconds, we start to produce the products which are green. So the reactants are getting less and the products are getting more. Then after 20 seconds, we have less purple and more green. And after the reaction finished, maybe 30 seconds, a lot of greens products and way too much less reactant, the purple ones. How can we calculate the average rate? Average rate it equals to negative delta concentration of reactant over delta time. That means the negative, the change of the concentration of the reactant divided by the change in time. That's when we talk about the reactants, we put the negative sign, which equals to positive delta concentration of the products divided by delta time. Because the reactants is always being consumed, that means by the time the concentration of the reactants is getting lower. That's why we put the negative sign here, because the average rate has always positive sign. But before we continue, we need to understand what is meant by concentration. And usually when we talk about the concentration, we talk about the molarity. So let's have a quick revision about the molarity, which is the number of moles of solute per liter of the solution. We are talking about the number of moles of solute and the volume of the solution. So look at the table salt here, the NaCl. This is the solute, and before we dissolve it in water, this is the water here, and this is the solvent. Now, after we dissolve the table salt in the water and mix it, we will form a homogeneous mixture. That is the solution. So the solution is basically the solute plus the solvent. How can we calculate the molarity or the concentration in molarity? Usually we give it the letter M capital or sometimes C capital in other books. For now, we're going to use it as M capital, which equals to the number of moles of solute divided by the volume of the solution. Some students, they make a mistake. They write the number of moles of solute over the volume of the solvent, which is incorrect. It should be the volume of the solution. And the unit of moles is mole. The unit of the volume, usually it's in liter. And we give the molarity this unit, mole per liter, or M capital, which means molar. Now, what is the number of moles? The number of moles, to calculate the number of moles, it equals to the mass in grams over the molar mass, which is in gram per mole. And the unit of number of moles, of course, is mole. What is the molar mass? Molar mass, we get it from the periodic table. So for example, if we are talking about the molar mass of H2O, It equals to how many atoms of hydrogen in this formula? We have 2. So it's going to be 2 multiplied by the mass of the hydrogen from the periodic table, which is 1, plus we have 1 oxygen atom multiplied by the mass of the oxygen atom from the periodic table, which is 16, and that equals to 18 gram per mole. It's very important to revise the concentration molarity because we're going to use it a lot in the rate of chemical reactions. Now, what is the collision theory? To study the rate of chemical reaction, we need to understand the collision theory, which says all atoms, ions, and molecules, they must collide in order to react. But you will see that it's not only about the collision between the atoms, ions, or molecules. We need to have other factors in order for a chemical reaction to occur. So for example, if we have here this molecule AA, which is A2, it's reacting with BB, which is B2. And you will see that they will start colliding with each other, just like what you are seeing here. Some of the particles, they are colliding with each other, and they produce the product. But before we produce the product, we have something called the activated complex, as you can see. And this activated complex will lead to the AB and another AB, that is 2 AB molecules or the products. But look here, for example, if we have AA and BB the same and they collide with each other, they will form a different activated complex and there is no reaction. They will collide with each other and then they will rebound, giving if we start from A2 and B2, they will also give you A2 and B2 and there is no reaction because they rebound. So what are the factors that are needed in order to create the activated complex which lead to the products? First of all, we need the correct orientation. So this one, it's a correct orientation because the collision will yield to the products. But this one is incorrect orientation because those molecules will rebound. There is no reaction between them. So we have two factors. We need correct orientation, and sometimes even if we have the correct orientation, there is no chemical reaction because this collision also it needs sufficient energy. If this collision doesn't have the enough energy to make the activated complex and then the product, that means also the molecules will rebound and they will not have the products. They will not yield to the products. Now, what is meant by the activated complex and activation energy? The activated complex is a temporary and it's unstable arrangement of atoms in which old bonds are breaking and new bonds are forming. So look here, this is the activated complex. It's temporary, it's unstable arrangement of the atoms, as you can see, A, B, B, A. And those old bonds are broken, those old new bonds are formed, but it's unstable. Now, what is the activation energy? Is the minimum amount of energy that is required for a chemical reaction to occur, or is the minimum amount of energy that reacting particles they must have to form the activated complex and lead to the reaction or lead to the products. We call it the activation energy. We will get better understanding when we study this graph. So in this graph, for example, CO is reacting with NO2. These are the reactants, and they have specific energy. It's right here. Now, when you give it the minimum energy for this reactant in order to create the activated complex, we call this energy EA, which is the activation energy. So basically here, the difference between the reactant and the activated complex energy is called the activation energy. That is the minimum amount of energy for the reaction to occur. After the reaction creates or yield to the activated complex, which is unstable arrangement of the atoms, as you can see, and its temporary product, it will go to the products to yield to the products which are CO2 and NO. And if you remember here in thermochemistry, we studied that delta H, the change in the enthalpy, it equals to the enthalpy of the products minus the enthalpy of the reactants. So it's going to be from here, from this point to this point. And because it's exothermic reaction, the products has lower energy than the reactants, then the negative sign should be included. Look at the other reaction now. CO2 plus NO2, we have this activation energy from the energy of the reactants to the energy of the activated complex. And we call this the activation energy for this reaction. Now, this activated complex, also its temporary and unstable arrangement of the atoms, it will lead to the products which are CO and NO2, which have slightly lower energy than the reactants. And this is the delta H. Also in this example is going to be negative sign. All right. Now, let's do the self-check about this section before we start our next lesson in the next video, which is about the factors that affect the rate of chemical reaction. The first question is, which of the following theory states that the atom, molecules, and ions must collide for a chemical reaction to occur? Is it the collision theory? Is it the accident theory, the reaction theory, or mechanism? You have to choose the correct answer. Question number 2, when the bonds break down into chemical B at T equals to 0, the concentration of A, it was 0.1 molar, and at T equals to 10 seconds, the concentration of A equals to 0.075 molar. What is the average reaction rate? I'm not going to give you the answer, but I'm going to give you a hint. The rate of the chemical reaction, or the average rate of the chemical reaction, it equals to, because here we are talking about the reactant A, so it equals to negative the concentration of A divided by, of course, delta, divided by delta T. You know delta A because you have the final, which is 0.075, minus the initial, which is 0.1 molar, and delta T is between 10 seconds minus 0 second. This is the T1 and this is the T2 or T final, and this is the T initial. You calculate it and you will find the average rate of this chemical reaction. This question, for example, how much time has passed when 5 moles per liter, as you know, mole per liter is the molarity, that means the concentration of the reactant, have reacted, that means it's the reactant, at the average rate of mole per liter second. This is the average rate. Now, if you want to implement or apply this equation, you have the average rate, which is 0.5 mole per liter. You have the delta concentration of the reactant, which is 5 mole per liter, because this is what already reacted, and you need to find delta T. So if you start from 0, what is the T final for this reaction to occur? Also, it's simple. Try to solve it by yourself. This question, what is the name of the unstable molecule formed during the collision of A2 and B2? What is the name of this? Is it product, reactant, activated complex, or diatomic molecule? The last question, the activation energy is the energy released by a chemical reaction. Is it the energy absorbed by a chemical reaction? The energy reacting particles must have to form an activated complex, or the energy produced by combustion of the reactants? I think it's a very nice and simple question. I hope you guys learned something new today. If you have any question, just write it down in the comments. I will read all the comments and I will answer all your questions. Have a nice day. Bye bye.